Okay, so my topic is cryptology, and we are going to start it now. Okay, so my topic is cryptology, and I chose this topic because I was flipping through my number theory book, and I really wanted to learn about it, and we didn't get to it. And my mom also plays this game online, and she really likes it, so that's why I chose this. So, here we go. So first we are going to learn some terms in order to be able to encrypt and decrypt the systems. So cryptology is the study of secrecy systems. Cryptanalysis is the breaking of systems, which is encryption and decryption, which is what we are going to talk about. So encryption is changing plain text into ciphertext, whereas decryption is the inverse of that, which is ciphertext into plain text. Plain text is the original message, so if I wanted to send one of my friends a message and say, hey, let's meet later, that would be plain text, where ciphertext would be changing that message into numbers and then later on a different message that is unreadable. Keys. Every system has to have a key in order to encrypt and decrypt it to figure out what it is. It determines the transformation from a set of possible transformations, and ciphers are characteristics that are changed individually into another letter by substitution, which is what our first system includes, which is the Caesar cipher. This dates back to when Julius Caesar was around, and he helped out using this. This is one of the first general systems, so it's really basic. They have come out with much more elaborate systems since then. So we use this equation in order to encrypt using the Caesar cipher. C stands for the ciphertext, which is what we were trying to get to, and whereas P is the plaintext, and K is our transformation, where we are transforming the text from. As you can see, we have our plaintext in this table, and our equation is in modulo 26 because from A to Z there are 26 letters, and we are going from 0 to 25, where 0 is 26 in modulo 26. So if I had the message to encrypt as John Jay is my favorite player, I know that last night he had a rough game, but you know what? I like to support the underdog, so he's my favorite. So if I was going to encrypt this message, first I am going to set out and write down what each of these letters are in the plain text. So where J is, I believe, like 9th. Also, K can be, you can transform the plain text along any number you want. I could have picked 8 or 10 or 12. It has to be in between 0 and 26. So then I used this equation, and here we can see that J is 9 as stated previously, so we're going to do 9 plus 7, which is 16, and in modulo 26 it is still 16. And you can see right under it, the ciphertext is Q, so now my J is a Q. Whereas O would be 14 plus 7, so that gives me 21, so that would be V. So as I go through and I encrypt all of it, I then get this message, which has nothing to say for John Jay is my favorite player. As we stated, to decrypt the message, it's the inverse, so we are going to use the following equation as P is congruent to C minus 7 modulo 26. When I go through and do that, I have Q, so have Q, which is 16. 16 minus 7 is 9. So now my plain text character is J, which we know is true because then we get back to this statement. The next system is a name of which I cannot pronounce because I'm not good at pronouncing names, but he was a diplomat and he was a cryptographer, and he wanted a system that was a little more complex than the Caesar cipher, so he came up with the following equation, where C sub L is congruent to P sub L plus K sub L modulo 26, where C sub 1 or C sub L, it should be, is from 0 to 25, and L can be any number 1 through N, depending on how long your message is. So if I had my name, Colleen Elizabeth, and in this system you need a keyword, which mine is Waka, as you can see, is Carnold's themed, and so since Waka is in length 5, then I'm going to split up my name into length 5, hence it's a block cipher as stated previously on the slide. So my name is not in groups of 5 though, so I have that H is by itself. So you can pick any letter to add to the end so that it is in groups of 5. So it will be, one group will be C-O-L-L-E, the next is E-N-E-L-I, the next is Z-A-B-E-T, and then the next is H, and I picked X's, so it's going to be H-X-X-X-X. So that is me breaking my message up into equal groups. Then we're going to translate it into numerical equivalents. So C is 3 if we're using the plain text box from before, and then we can go on so. We also translate the key word, which is Waka, into numerical equivalents. So W would be 22, A is 0, C is 3, H is 7, I believe, and A is 0. And then we use our equation to encode or encrypt. So when I do that, I have my P, if I go back, 2 slides, it's C sub 1 is congruent to P sub 1, so since my first letter of my name is C, it would be 2, so it would be 2 plus 22, and that would be 24, and so then it would be the 24th letter, and that would be Y, so then it would be Y like we have right here, and you keep going. Once you get to the next block, though, you start over, so since it's K sub L, you go the first plain text plus, K sub 1, then it's plus K sub 2, plus K sub 3, plus K sub 4, plus K sub 5, and then you're at the end of our keyword, and you start over for every block. As we stated, to decrypt, it's the inverse, so then we do P sub 1 L is congruent to C sub L minus K sub L, and so then we have we'll have the Y, which is 24 minus minus 22, because that is our W, and then we're back to 2, so we get a C. And the person who is decoding has to have our keyword in order to decode the message. Okay, so next, then we would get back to Colleen Elizabeth, which is my name. The next is the public key cryptography. This is the main method. It's even more complex. You have to use the computer in order to use this method because the modular arithmetic gets so large. These are some key theorems. Backing up though, this method is used, what banks use and military bases use, in order to encode and decode messages so that they know maybe when to attack or whatever they are trying to do, invade, etc., whatever they do. So these are the main theorems. The bottom theorem is one that is very focused, heavy, in this system. The top two are what we use in order to make sense of the last theorem. Okay, so moving on. So if we are given our E is 3, so backing up, we see that E is in this last statement, and use like a bunch of different methods. In this bottom theorem, you use the Euclidean algorithm in order to find out primes and everything else. So if I already did my Euclidean algorithm, I already know my distinct primes and everything, then I have come to the conclusion that my E value is 3 and my N is 2,773. And we want to encode the message go cards. We are going to split up the message so that each value does not exceed 2,773. In this grouping, we split them up as in 2 digits per letter. So the space is 00, whereas A is 01, B is 02, etc., all the way until we get to Z, which in this case, in this system, will be 26. So we split them up, and so that we have our plain text up here, as you can see. We split them up so that they're not exceeding 2,773. So the G is 07 and the O is 15. So that number is not exceeding 2,773, which is great, and neither are the rest of them. That being said, we can now move forward into encrypting it. So to encode this, we use the least residual, so that we have our number, which is 715, and we put that to the power of E modulo our N, which is 2,773. So when we get that, that number is congruent to 107, which we use Excel for, and since 107 is not a four digits, which is what we need so that we can get back to our ciphertext, then we put that 0 out in front of it. Again, we do that whenever the numbers are not in 4 digits. 3 to the third is not 4 digits, it's 2, so we put 2 zeros in front. The next number is 4 digits, and the following is not, so we put a 0 in front. So now we can break up each of those into 2 parts. So 01 is A, and etc. 07 is G, I'm sorry. And we can use our plain text model to see what it is. So we have, when we encrypt it, we have AG space ANPCK. Nobody is going to know that means go cards except for us and whoever has a keypad to be able to decode decrypt what we have. So when we decrypt, then we take that 107 and we put it to the D power, because we know that decrypting is the inverse of encrypting. So since we put our number to encrypt to the E power, now we put it to the D power. When we do that, we will get go cards, and that is the public key system. So that is the 3 systems, from basic to complex to what we are using now, and that is it. I hope you enjoyed.